Void Atlas, Part 1. NASA found a planet where the sun never rises. Imagine standing on a planet where the sky is permanently dark. Not because clouds cover the atmosphere, not because the planet is buried in shadow, but because the sun never rises. For the people who might someday explore such a world, there would be no sunrise to mark the beginning of a day, no golden morning, no familiar path of light crawling across the horizon, just darkness. And yet, this planet may be real. Astronomers have discovered worlds so close to their stars that their surfaces could be locked into permanent day and permanent night. One side faces the star forever, the other never sees it. And that raises a terrifying question. What would happen on the side where the sun never rises? And the answer may be far stranger than simple darkness. Far beyond our solar system, astronomers have found planets orbiting their stars at astonishingly close distances. One of the most extreme possibilities occurs when a planet becomes tidally locked. This sounds strange, but the basic idea is surprisingly simple. Our moon is tidally locked to Earth. That is why we always see nearly the same side of the moon from Earth. Now imagine the same process happening to an entire planet, but with its star. If a planet gets close enough to its star, the star's gravity can gradually slow the planet's rotation. Eventually, the planet may rotate exactly once for every orbit around its star. One rotation, one orbit. The result? The same hemisphere always faces the star. The opposite hemisphere never does. On the planet's permanent night side, the sky would look nothing like Earth's. There would be no sunrise, no sunset, no moving shadow line crossing the landscape each day. Instead, there would be a permanent boundary between light and darkness, a region astronomers call the terminator. And this strange zone could be one of the most interesting places on the entire planet, because it would sit between two extremes. On one side, relentless starlight. On the other, eternal darkness. But here's where the story becomes even stranger. A planet does not necessarily need to be completely frozen just because one side never sees its star. If the atmosphere is thick enough, winds can transport heat from the illuminated hemisphere toward the dark side. That means the planet's atmosphere could act like a gigantic planetary heating system. Heat rises, atmospheric currents move, energy crosses the planet, and some of that energy could reach the world where the star never appears. But scientists still face a major problem. We cannot simply photograph these distant planets like we photograph Jupiter or Mars. Most are so far away and so close to their stars that the star's light completely overwhelms the planet. Instead, astronomers often detect them indirectly. They watch for tiny changes in the star's brightness. A planet passing in front of its star can block a microscopic amount of light, and when a planet's gravity pulls on its star, the star can wobble slightly. These subtle signals reveal something extraordinary. A world is there, and sometimes the data can even reveal clues about its atmosphere. That is when the invisible planet becomes a scientific mystery, because hidden inside the light from a distant star may be evidence of clouds, gases, temperature differences, and possibly conditions completely unlike anything on Earth. But there's one final question. If the sun never rises on one side, could anything survive there? And the answer may be far stranger than simple darkness. Void Atlas, Part 2. The answer begins with something we often take for granted. A planet does not have to resemble Earth to remain active. On a tidally locked world, the permanent night side could be brutally cold, but not necessarily lifeless. If the atmosphere is dense enough, winds could carry heat from the star-facing hemisphere into the darkness. And beneath the surface, another source of energy could remain hidden: geothermal heat. Deep inside a planet, radioactive elements and leftover heat from its formation can continue warming the interior for billions of years. So even beneath an apparently frozen landscape, liquid water might exist underground. And that possibility changes everything, because life, at least on Earth, does not always require sunlight. Deep beneath our own oceans, ecosystems survive around hydrothermal vents, places where chemical energy from the Earth's interior supports life without direct sunlight. So, on a distant world where the sun never rises, scientists cannot simply say, dark means dead. But there is another extreme. The permanent day side could face the opposite problem. Imagine a hemisphere receiving constant radiation from its star. There would be no night to cool it down. If the atmosphere is thick enough, temperatures could become intense. Atmospheric circulation would become critical. Powerful winds could continuously transport energy from the hot hemisphere toward the cold hemisphere. The result could be a planet divided into radically different environments. One side illuminated forever, one side dark forever, and between them, a narrow region where conditions might be far more moderate. This is why scientists are especially interested in the terminator zone. It could potentially contain temperatures that are neither brutally hot nor permanently frozen. Not a paradise, not an Earth-like world, but perhaps a place where chemistry becomes unexpectedly interesting. And this is where NASA's powerful space telescopes become important. Observatories such as the James Webb Space Telescope can study the light passing through or emerging from exoplanet atmospheres. When a planet crosses in front of its star, some starlight can pass through the planet's atmosphere. Different gases absorb different wavelengths of light. By studying those patterns, astronomers can determine what chemicals may be present hundreds or even thousands of light years away. It's almost like analyzing fingerprints, except the fingerprints belong to an entire atmosphere. And every new observation can eliminate one possibility while revealing another. A planet that looked completely inhospitable from a distance may turn out to have an atmosphere capable of moving enormous amounts of energy. Another may have almost no atmosphere at all. And if the atmosphere is stripped away, the permanent night side could become an even more extreme frozen wasteland. But there is an important correction to the phrase, "the sun never rises." For these worlds, the star may not literally be our sun. It could be a red dwarf or another type of star. And red dwarfs create their own problem. They're smaller and cooler than our sun, so a planet must orbit much closer to receive enough energy to potentially remain warm. That close orbit makes tidal locking much more likely. But red dwarfs can also produce powerful stellar flares and bursts of radiation. So a planet may face a strange contradiction. Its star provides the energy needed to keep parts of the planet warm while simultaneously threatening its atmosphere. And yet, despite all these possibilities, scientists have not found evidence that a tidally locked planet actually contains intelligent life. That distinction matters. The discovery of an unusual planet is not the discovery of aliens. What scientists have discovered is something more fascinating in its own way. Nature can create planets with environments so extreme that our Earth-based intuition begins to fail. A world where one hemisphere experiences eternal daylight, while the other remains in permanent night. A world where the most interesting place may not be the day side or the night side, but the thin boundary between them. And somewhere in the darkness, hidden beneath ice, rock, and an alien sky, there may be chemistry we've never seen before. Perhaps even the ingredients for life. The sun may never rise there, but that doesn't mean the story ends in darkness. Because every time astronomers discover another strange world, they're forced to reconsider one of the biggest questions in science. How many different ways can a planet become alive? And we may have just begun to find out.